tiny spark from static electricity can be thousands of volts. While it may only hurt a little bit to human beings, it can easily destroy the parts we use to build computer boards here at Artesyn. Because of this, we wear special clothes that prevent static from building up. We need to make sure to test these before we enter to make sure we won't hurt anything in the manufacturing area. These are bare boards, and they are the start of the manufacturing process. They're specially designed for us to hold the computer parts we will be adding later, and they're loaded at the very start of the assembly line. The bare boards feed into this machine, which will put solder paste in just the right places on the board by pushing it through a specially designed screen. We'll add electronic parts, then heat up and melt the solder. Once it cools, it will be very hard and will hold these parts to the board. Not only does solder hold the parts physically in place, it conducts electricity, so all of the parts can interact electronically on the board. The next step is adding glue to the board. We do this for some parts that need extra help sticking to the board, or which might be washed away by a later step called wave soldering. After this is done, we take a close look at each board to make sure all of the glue and solder paste is where it needs to be. Now that we've prepared the boards, it's time to start putting parts on them. Most components are fed into our machines on these big reels, each holding hundreds of individual parts. The boards move into our high-speed placement machines, which we call a chip shooter. You can see why. It's very fast and can shoot hundreds of different parts onto a board in a matter of a few seconds. Because the assembly line is so long, there are special gaps where people can pass through. When a board needs to move to the next piece of equipment, these shuttle conveyors automatically extend across the gap. Some parts need to be put on the board more slowly and carefully, so we use another machine that's much like the first chip shooter but more accurate in placing the components. After this, we inspect the boards once again.
Looking for correct placement orientation, looking for bent leads, looking for missing parts.
When we're sure all the parts have been placed on the boards correctly, they're fed into the reflow oven. Essentially, it's just a slow ride through a very hot place. The heat melts the solder on the boards, and after the solder cools, the parts will be permanently connected to the boards. After the trip through the reflow oven, it's once again time to inspect the boards. We need to make sure that all the parts are where they should be and the solder looks like it's melted and then cooled properly. Because many of the components we use on our boards have lots of small connections which aren't visible to the naked eye, we also inspect them using this, an X-ray machine. Just as the doctor can see your bones using X-rays, we can see right through the board and parts to see all of the solder connections underneath. We need to make sure that they all look as they should be before we go on to the next step. Some parts can't be put on by machines at all, so we have to add them manually. These parts have long leads or wires that extend through the board and come out on the bottom side. After the components are put on by hand, they're fed into this, the selective soldering machine, which is also called a wave solder machine because it has a continuously flowing wave of molten solder. The robot arm is programmed to dip the board into it at just the right places to solder on the parts we've added by hand. The boards are almost complete. The final step before they're done is to add any non-electronic parts that may be needed by our customers, such as screws or faceplates. Now that the boards are finally done, they still have to go through a round of testing to make sure they're good enough to deliver to our customers. The ICT, or in-circuit test machine, actually probes the boards electronically. Then we do a functional test to make sure that the boards work as expected. We also run them in a burn-in chamber, which cycles between hot and cool to give a good stress test. After all of this, it's time to wrap the boards in special bags which protect them from static electricity, label them properly, and then box them up to send to our customers. The manufacturing process is finally complete.